Hey guys, in this video I'm going to be talking about multiplying polynomials. In the first part, I'm going to talk about how to multiply a monomial by a polynomial. And then in the second part, we're going to be multiplying two binomials. That part will be a two-part video. In the first part, I'll show you how to do it with algebra tiles. And in the second part, I will teach you how to do it using something called the box method. So let's start up top with the monomials times the polynomials. So basically all you need to do is the distributive property, but you need to remember the exponent rules. So remember, when multiplying exponents that have the same base, keep the base, add the exponents. So if I distribute 3x to each term inside the parentheses, I have 3 times 2, which is 6, x times x squared, which is x to the 1 plus 2, which is 3 times negative 5, which is negative 15, x times x is x squared, and then we have 3 times 3, which is 9, and then the x comes with it. And that's it. That's all you have to do for A. B is similar. So we have negative 4 times 2, which is negative 8. X squared times x squared is x to the 4th. Negative 4 times this invisible 1 here is negative 4. X squared times x is x to the 3rd. Negative 4 times negative 7 is positive 28, and the x squared comes with it. And that would be it for that one. Now part C, same idea, except there are just more terms. This 8 is supposed to be right here essentially, so I'm just gonna fix that. Okay, so negative 3 times 6 is negative 18. B to the 3rd times B to the 4th is B to the 7th. Negative 3 times negative 3 is positive 9. B to the 3rd times B to the 3rd is B to the 6th. Negative 3 times positive 9 is negative 27. B to the 3rd times B squared is B to the 5th. And negative 3 times negative 8 is positive 24, and the b to the 3rd comes with it. And that is how you would multiply a monomial by a polynomial of any size, whether it's just one other monomial, binomial, trinomial, or polynomial. All right, so let's talk about multiplying two binomials. I'm going to do a couple on each side that show you how to do it using algebra tiles, and then I'll make a second video on how to do it using the box method. So this first one here is x minus 2 times x minus 3. So I'm going to move the paper over here, and then I will show you how to do this using algebra tiles. So what we want to do is represent each parentheses using the algebra tile. So first I have x minus 2, so that's a green stick and 2 red little squares. So what I'm going to do is create the sides of a rectangle with this. And then the other one is x minus 3. So that's another green x. And this time 3 red little squares. So essentially what's going on here is we are creating something called an area model. So I want you to use those sides of our rectangle to create the area of our rectangle. So what I'm going to do is multiply each section to fill in the rest of the rectangle, which will help us decide what this binomial times this binomial gives us. So we have an x times an x, which remember is x squared. So that's a big square. It's blue because it's positive. Then we have x times a negative 1, which is negative x. So that's a negative or a red rectangle. X times negative 1 again is also a red rectangle. Then we have negative 1 times x, same thing. And that's going to happen 2 more times with each of these. So I'm going to add 2 more red rectangles. And then lastly, we're going to multiply the negative 1s. So negative 1 times negative 1 is positive 1. So that's a yellow little square. And that's going to happen multiple times. We have negative 1 times negative 1 again, which is also positive 1. Negative 1 here times negative 1 here is a positive 1. And that's just going to keep happening. Negative 1 is positive 1. And then once again, this very last square gets multiplied by each of these. So that's going to be 2 more positive 1s. Now, when you go to get your final answer, you can remove the sides that we started with to help us find our rectangle. And what's remaining will give you your answer. So start with the biggest exponent, which is this squared. So I have x squared. Now count the rectangles. 1, 2, 3, 4, 5 negative rectangles. So it's negative 5, which is an x, so negative 5x. And I have 1, 2, 3, 4, 5, 6 positive 1s. So that is plus 6. So this binomial times this binomial is x squared minus 5x plus 6. And that's it for that one. Let's try another. All right, let's skip down to number 5. So number 5 is x minus 4. So I have x 1, 2, 3, 4 red ones, or 4 negative ones, okay? And then I have 5x plus 3, so I'm gonna need more space here. So 5 x's, so 1, 2, 3, 4, 5. I'm not sure that all of this is gonna fit in the picture. I'll have to zoom out here. Or maybe I'll go across this way. 1, 2, 3, 4, 5. So let's zoom out a little. So I have 5 x's, so it was 5x plus 3, so that's 3 yellow ones. 1, 2, and 3. And then the other one I'm going to put back, that was x minus 4. 1, 2, 3, 4. Okay, and then we multiply. So I have positive x times positive x, which is x squared. And that's going to keep happening. Look, x times x is x squared, x times x is x squared, x times x is x squared, x times x is x squared. So I'm going to fill all of those in with blue big squares. The problem is I'm not going to have enough. So I'm going to have to remember that there is another one right here. Okay, another x squared right there. And that's where the box method is going to come in handy later, but we'll learn that in another video. All right, so now we have x times positive 1, which is a positive x. And that's going to happen 2 more times. And then we will move down to multiply my negative 1s. So I have negative 1 times positive x, so that's going to give me a negative x. And that's going to happen a lot here because each one of these negative 1s is being multiplied by that x. So I'm going to fill this space in here, and then it's going to happen here with this x, with this x, with this x, and with this x. So I assume I'm going to run out of rectangles here, but we will try. And I have officially run out of red rectangles. So I need to remember there's a negative x here, 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 and here. And also here, 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 and here. Once again, the box method will help us with this a lot. Now down here in this corner, I am multiplying my negative 1s by my positive 1s. So each time, negative 1 times a positive 1 is going to give me a negative 1. So I'm going to use a lot of little red squares here. Okay? Negative 1 times this positive 1 is also a red square, as is the last one. Then I'm just going to move down the column here. So I have this negative 1 times each of these positive 1s, which is going to give me 3 more negative 1s. And then the same thing. This negative 1 times each of these positive 1s is going to give me 3 more negative 1s. And this negative 1 here times each of these positive 1s is going to give me 3 more negative 1s. Just like that. All right. Now, again, imagine that this space is filled up with what we put there, and now we can remove what we used to find our rectangle, and we have our answer. So let's count it up. I've got 1, 2, 3, 4, 5 positive x squareds. So when I put this on my paper, I'm going to put 5x squared. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 red x's. So remember, that is negative 20x. So negative 20x. I also have 1, 2, 3 positive x's. And I have 3, 6, 9, 12 negative 1s, or negative 12. So when I put all that on the paper, let me show you what I've written. I have this. Now this time you should notice that I have negative 20x and a positive 3x. Those are like terms. So I can combine those together. I'm going to put these two things together. So I have 5x squared. Negative 20x plus 3x is negative 17x. And then bring down your minus 12. And that would be your answer for that one. All right, let's flip it over and try a different one. We're going to try two of each of the special types here. We got multiplying two binomials and a binomial squared. All right, so the first one we're going to do is x plus 3 times x minus 3. So x plus 3 and x minus 3. Okay, same idea. Find the rectangle inside. X times x is going to be x squared. X times positive 1 is x. And that's going to happen again. X times positive 1 two more times is going to give me two more green rectangles. And then down here I have negative 1 times positive x, which is a negative x. Negative 1 times x is negative x. Negative 1 times x is positive x again. Then over here, I have negative 1 times positive 1, which is negative 1. Negative 1 times positive 1 is negative 1, and that's just going to keep happening all the way across. And then again, negative 1 times each of those positive ones gives me 3 more negatives. And the same thing at the end. Okay, I have filled in my rectangle. I can remove my measurements on the outside and write down what I've got. So I've got an x squared, 1, 2, 3 x's, 1, 2, 3 negative x's, and 3, 6, 9 negative 1s. Okay, once again, I can combine like terms. Now what's going to happen here is 3x plus negative 3x is 0. So those cancel out, and I'm left with x squared minus 9. And that would be my answer. Let's try another. So we got 2x plus 6 and 2x minus 6. So 2x is here, 2x is here, positive 6. And a negative 6. Okay. All right. Same idea as before. X times x is x squared. X times x is x squared. X times x is x squared. And x times x is x squared. So we have 4 x squareds. Now each of these yellow ones is going to be multiplied by this green x. And x times 1 is just x. So I'm going to fill in all of this space with some green x's. And again, I anticipate running out. So we'll have to do something about that. All right, that's all the green x's I've got. So I'm going to erase this that I had from one of the other problems. And I know there's a positive x here, 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 and here. Now down here, I'm multiplying a negative 1 by an x, and that all of this is a negative x, and then x times negative 1, all of this is also negative x. So let's fill all that in. Okay, so I've got my negative x's filled in. And then this corner over here, I'm going to have negative 1 times positive 1 for each of these. So all of this is going to be filled with negative 1s. So let's do our best to fill that in here. Definitely going to run out. So I'm going to go this way to make sure we know how far it goes. All right, so that's all of the negative ones I have. So I know lots of negative ones here, here, here. All right, now I have filled in my rectangle. I'm gonna zoom out a little bit, I think. We can remove the sides. And then we can count up our answer here. So we have 1, 2, 3, 4x squared. And what I'm going to do this time, instead of combining like terms, is I'm going to remove things that make 0 pairs. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 green x's, and I have 2, 4, 6, 8, 10, 12 red x's. So I can literally just eliminate all the x's I've got, including the ones I wrote. So let's erase those. Now down here, I have 1, 2, 3, 4, 5, 6, and there are 1, 2, 3, 4, 5, 6 rows. That's negative 36, so minus 36, which means my answer is 4x squared minus 36, which is what I've written on the paper. All right, let's try 2 more. We've got x minus 5 squared. So I need you to keep in mind that when you're squaring something, it means you're multiplying it by itself. So this is not taking this 2 and squaring everything inside. It's really x minus 5 times x minus 5. So let's do that. I'm going to take an eraser and get rid of what's on my desk here, just so we have a nice clean space to start. Okay. All right, so we have x minus 5, so that's a positive x, and a negative 5. Here's 3, 4, 5. So x minus 5 times x minus 5. All right, let's do it. X times x is x squared. Then x times each of these negative ones is going to give me negative x's. So I'm just going to fill in this side over here with some negative x's. And the same thing's going to happen down here. I've got x times negative 1s, so those are also negative x's. And then I've got negative 1s times negative 1s, which is positive 1s. So all of these areas are going to be made up by positive 1s. So let's fill that in. And I think I might run out. Let's see. I'm approaching that moment. All right, that's the last one I've got, which means I also have one here and all the way across. So again, remove the outer edges. All right, and I've got x squared. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative x's, so negative 10x. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 times 5 is 25, so positive 25. So my answer is x squared minus 10x plus 25. All right, let's do one more. This last one here says 2 groups of 4x plus 5 squared. So remember, this means 2 times 4x plus 5 times 4x plus 5. Okay, so what I'm going to do is do the 4x plus 5 times 4x plus 5 and then times it by 2 because I have 2 of them. So let's do that. I'm going to run out of space, but it'll be okay. All right, so 4x's and 5 1s. And then same thing on the side here. I'm gonna have to zoom out for sure on this one. And I still probably won't have enough space. All right. All right, we'll do our best here, but I can't zoom out much more. All right, so we have all these green x's being multiplied by all of these green x's. And remember, x times x is x squared. So all of this is going to be filled in with positive x squareds. And I only have 4 of these, So once again, this type of problem is best done with the box method that I'm going to talk about later. But for now, this is what we got. So remember, all of this is filled in with x squareds. Okay. Now each of these yellow ones is being multiplied by each of these green x's. So all of this on the side here is going to be filled in with green x's, which again, I'm going to run out of. So we'll do our best here. So I literally only have 4 of them left. Okay, so we're going to have an x here. Maybe I should go this way so we know how far down they go. Now, the problem is each one of these yellow ones down here at the bottom are also being multiplied by the positive x's. So I have a bunch of green x's down here at the bottom too. So I'm going to fill them in. Okay. So that's all the x's. Now my ones, I have 5 of them here and 5 of them here. So I'm going to multiply those and fill it in down here. So it's 1 being multiplied by 1 5 times this way, and we'll fill it all in. Or try to. So 1, 2, 3, 4, 5. And it also goes along the sides as well. So 1, 2, well, that's 3 actually, 4, 5. And I'm out of tiles again, so there are ones all along here. All right, now we can count up what we got. So get rid of the outside, and let's count it up. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 x squareds. So I'm going to write that down. Okay, then I've got 1, 2, 3, 4, 5, 10, 15, 20, 25, 30, 35, 40 x's. And I have 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5 is 25 ones. Okay, so if I'm looking at the paper, all of that work gave me this here. But remember, that is all being multiplied by 2, which basically brings us back to the first problem we did at the beginning of this video. So I'm going to distribute this monomial by this trinomial. So 2 times 16x squared. 16 times 2 is 32x squared. 2 times 40 is 80x. And then 2 times 25 is 50. So that would be my final answer. And that's how you use algebra tiles to multiply polynomials.